All right. Good afternoon, everyone. You've been patient enough listening to a lot of things that have been stated about 5G. So I'm here to speak a little bit more about 5G, specifically as to what is it that we are doing as a part of establishing a platform for the future. So when we take a look at all the use cases of 5G, we have to kind of think about the different industries that get transformed and industries that eventually get created as a part of introducing 5G wireless technology into those areas. On one hand, we know something very well today. That's enhancements in mobile broadband. The ability to get to very high data rates and extremely high capacity of the network, which is kind of very useful. On the other extreme, for the first time in cellular communications, we are placing emphasis on two other attributes of 5G that we've never actually talked about before: latency and reliability. When I'm using a smartphone, I have some sense of what a latency is, but I don't really care too much about the reliability part of it. But these two attributes, reliability and latency, are an important part of some of the new industries, which we'll talk about in a little bit. And finally, 5G eventually needs to go into a massive connectivity with IoT. We already have the beginnings of IoT today with 4G. Large number of devices do connect to the network as a part of 4G IoT today. What we are trying to do with 5G is to make sure that this goes at a much higher scale. And so that's why we call it as massive IoT. All these three applications have been shown in this slide, which is just a very high-level perspective of what we are trying to do with 5G. But as I said before, it's important to understand we are only laying the foundation for 5G. It's a platform for the future, and we just took the first step towards it. There's a lot more to come ahead of us. As we think of the overall economic impact of 5G, the numbers tend to be very staggering. In one of the studies that we recently did, you can see that there is a huge impact on overall society with $12.3 trillion. This is one of the impacts that we have found. This is a potential impact as we go into 2035 timeframe. Now, time will tell exactly what the impact is. The numbers are probably not as important as it is to understand that this is truly a transformative technology. Now, when we talk about 5G, there's so much to talk about. I only have 20 minutes. So I'm going to actually try to make sure that we address these key attributes so that you walk away thinking, okay, I get it. I know exactly where the changes are going to be. Here's a broad perspective of 5G. What are the different industries? It's going to transform the way we consume data on mobile devices, while at the same time creating new kinds of mobile devices. All of us have smartphones today. Tomorrow, maybe what we want to have is connected laptops in addition to that. XR, which is a combination of augmented and virtual reality headsets. These come under the category of mobile broadband devices. But in addition to mobile, we expect wireless connectivity to be very pervasive in enterprise applications. That's with mobile computing. Industrial applications, factory automation, smart cities, connected vehicles, vehicles connecting with other vehicles, and connecting to roadside infrastructure around them. This is just the beginning of what we think is going to be the overall transformation. Now, when we think about all these transformations that are occurring, one question is, well, what's happening right now on 5G? It is enormous the way 5G has actually started off in 2019. We have 6 to 7 different regions, which are simultaneously launching 5G as we speak. Today, you can walk into a store in the US, in Europe, in Korea, in Australia, and buy a 5G device and connect to a 5G network that's been turned on. Yes, it's spotty coverage. It's not everywhere yet. But 5G is here in 2019. In addition to that, we have the beginnings of 5G coming up, both in Japan and in China, and even some parts of Middle East have started taking the first steps towards this. This is historical. We've never done this before. Go back 10 years in time. In 2009-2010 timeframe, we had just a handful of mobile operators, maybe 2 or 3. All we had to do was launch 4G in just a few bands, and that was it. Today, we have 6 to 7 different regions with 5G going into TDD and FDD bands, below 6 gigahertz and millimeter wave, starting with non-standalone mode and eventually going into standalone mode. Enormous complexity is being built in from day one. And this is only the first year of 5G. We have a lot more to come. But already we are taking a very complicated set of steps to get there in a nice manner. Question number 1. What can I do with 5G that I cannot do with 4G? A lot of people have this question. We asked ourselves the same question. I can already get gigabit LTE today. Tell me again, why do I need 5 gigabits per second? Why do I need such high data rates? To understand this problem, it's important to actually first clarify that the emphasis of 5G is not so much on the peak data rates. It's about the average user experience and the cell-edge user experience. When I'm walking around the street, on an average, I want to get 100 to 200 megabits per second. Average, maybe 500 megabits per second. When I'm at the edge of the cell, I want a guaranteed minimum data rate of maybe 50 megabits per second. These sorts of numbers are significantly higher compared to what you see with 4G. And if you have that kind of a user experience, then the natural question to ask is, how do things change for me? Well, when we talk of use cases of 5G, it's important to understand there are 2 sets of use cases. We have use cases today. We download movies, download files, we play games. Those use cases get significantly better. So for example, if you take a look at any 5G device, yeah, the networks are not very loaded these days, but still when you walk around, you can see that there is up to a 20x improvement in the overall download latency. You reduce the latency significantly. Reduce the amount of time it takes to download a movie. At the same time, we all watch videos. I'd like to watch a video in 4K all the time. But it turns out that unless the average data rate is very high, on an average, a user will not be able to see a video in its native format. 5G allows us to do that. That's about 95% of the users actually get to see the video in its original format compared to what you would do with 4G. You could be cynical about it and say, well, these are use cases that I know, it's okay. But tell me more. What else can I do with 5G? There'll be a next set of use cases that are coming in with mobile computing, enterprise and industrial applications with factory automation, and connected vehicles. I'll talk about that in the subsequent slides. So bear with me for one more slide. One question, how many devices are there today with 5G connectivity built in? This is from Qualcomm's perspective. We have more than 75 different OEMs out there which have used our chipset, our overall solution, as a part of their 5G offering. Large numbers of smartphones, CPEs, modules, and CPEs used for fixed wireless access, in addition to mobile routers. So there is a very diverse ecosystem of devices today that you can already buy. So this is pretty good. This is a very good starting point for us. But as I said, let's really talk about a little bit more into the future as to what do we want to do. Now, when we talked about all the different use cases of 5G, we said enterprise segment, industrial segment, and automotive segment. Let's try to dive into that over the next 10 minutes or so. One of the most important things that actually Rakuten is doing as we speak is bringing the concepts of virtual RAN. The idea that if you have a base station, it's not one base station that has the antennas, the front end, the transceiver, the baseband, the layer 2 and layer 3 stack all put together. That's the traditional model. The new model, which Rakuten has truly embraced, and we feel very glad about that, and we are an integral part of that whole solution space and working very closely with our partner, Rakuten, is the ability to have distinct elements so that you can mix and match. You can get maybe just the layer 1 solution from one vendor. You can get the layer 2 and layer 2, 3 stack from a different vendor, attach it to a core in a nice interoperable manner. This allows for an IT-based mentality to finally start coming into the telco space. That's a pretty big thing. One important part of that is Qualcomm's offering on small cells. And that is something that we're also displaying out here at the booth, but it's an important and an integral part of this overall vision of disaggregating the RAN and virtualizing it. Okay, so what are these different use cases of 5G now? Let's start with something basic. CPEs. These are consumer premises equipment. There's a large cross-section of population in the world today that doesn't have mobile broadband connectivity at home. They just don't. They don't have broadband connectivity. The economics are not quite in their favor, especially when you have to start thinking of laying fiber and going all the way to residential homes, if not into apartment complexes. Fixed wireless access is actually changing that narrative quite significantly right now. For the first time, I'll talk specifically about millimeter wave. One can actually get to gigabit speeds at home using millimeter wave, using fixed wireless access with millimeter wave. But one of the things about millimeter wave is these are highly spatially directed beams. That means if, let's say, I'm the base station and we have 10 users in front, you can have one beam each to each of the 10 users and get 1 gigabit per second to each of them. So you actually have a much higher sum data rate, and each individual user's data rate doesn't go down just because the number of users is going up. This is called multi-user Mimo, and for the first time this is being brought to the table to provide this sort of access to users who never had mobile broadband before. Very powerful. It's taking off in a very big way in a lot of geographies, and looking forward to that. There was a question earlier in one of the panel discussions as to how do we see 5G and Wi-Fi coming together? Do they complement each other? Is one going to take over the other? What happens in a mobile enterprise? I have an enterprise today. We all have Wi-Fi-based deployments inside enterprises. Why do I need 5G in enterprises at all? The answer is this. If we take a look at the kind of connectivity that is needed in enterprises today, the demands are increasing quite a lot. You need to have extremely high data rates for users. We're not just doing email anymore. We are more often than not on either conference calls with Skype, telepresence. But what if you can actually do that on the go? Yeah, I would like to do that. The second part is something that 5G inherently brings to the table that we don't talk about: security. 5G-based wireless communications is an inherently secure way of doing things. And therefore, from an IT perspective, when you're inside an enterprise, you get secure connectivity from day one. It's a very powerful thing, especially when you're managing a large number of installed base of devices. We also have several teams that could be located in different locations, geographically separated. And so when you want to have a collaborative work environment, we want to make sure that all these teams can work together simultaneously in a far more rich environment. So in other words, with a combination of audio and video put together. That places enormous strain on the bandwidth requirements that are needed, which we can bring with 5G. So the natural question is, can we really get such high data rates? So we did some experimentation in Qualcomm. This is one of our buildings, and we have a layout of that building. This is the location of the Wi-Fi access points. And what we did is, in those locations, we added 5G millimeter wave access points. And we actually did a simulation over here to see exactly what the coverage would be. This is the heat map of how the enterprise coverage would look like. It's hard to read the text, but you can see that the 50th percentile, the median data rate in that area is 5 gigabits per second. 50% of the area, you can go in there and you get 5 gigabits per second. That is the power of 5G millimeter wave. That is what we want to bring inside an enterprise deployment. And that's what we are really looking forward to. Now, one piece of the puzzle is, that's the network side. How about the devices? Well, we are working very closely with the overall mobile laptop ecosystem to bring 5G connected laptops to the table. Users are on the go, data is on the cloud, and you're always connected to the cloud using 5G, no matter what. You don't have to worry about connecting to one access point or the other. You're simply connected all the time. Very powerful. From an overall collaborative workplace environment, here's an example of how things might look. Different teams in different locations, but how do you actually work together? You need to have these XR glasses with which you see exactly the same phenomenon that is being seen from another team. To do that, you need edge computing capability. Mobile edge computing is a very important piece as we bring this sort of connectivity to the table with 5G. So you can see that in the background, there is a server where all the processing is being done, especially for XR, by the way. It tends to be very process intensive. So you can outsource some of that processing into the edge computing server. That makes these XR glasses far smaller and simpler, and they become much more sleek. And they look much more, they're easily put on top of your, like wherever you want to actually use them, compared to where we are today with the head-mounted displays, which tend to be far bigger in size. Let's switch gears to applications in industries. If you take a look at a manufacturing plant today, and here's an example of a car manufacturing plant. I used to think that when you manufacture a car, maybe you start some point in the assembly line, and you finish it, and towards the end, you add cellular connectivity to it. Wrong. That is not how it works. In fact, most of the factories are actually thinking of having that cellular connectivity a little earlier, so that as the vehicle is still getting manufactured, you collect a lot of analytics from it. You actually get a lot of data, you're processing it, you're computing a lot of analytics, and based upon if there is an issue in that, you turn it around in the middle of the assembly line. So it's a significant improvement in the overall productivity of the manufacturing line itself. That's the reason why manufacturing plant owners and industries are very excited about 5G. That's what you get with wireless connectivity over there. Imagine doing the same thing with a wire. Impossible. You're going through an assembly line, it doesn't quite work that way. You can generalize it even further. Here's how an actual manufacturing plant looks like. It's very chaotic. There's an industrial robot. There are AGVs that are moving around. There's a person with a head-mounted display. There are sensors. There are cameras. There's analytics. All of this is going on. But from an engineering standpoint, what you want to say is, well, what is 5G about all of this? Okay, let's take a look at the requirements of each of these things. That industrial robot in the middle, it does not care about very high data rates. What it needs is less than 1 millisecond latency with a reliability of 10 to the power of -6 or so. That's a 5 to 6.9 reliability that is needed. That's ultra-reliable, low-latency communication. The head-mounted display that the industrial worker is wearing, that happens to be close enough to a mobile broadband device. Typically 100 to 500 megabits per second that is needed. Because when you wear that display, you can just look at a machine and you get all the KPIs that you can see in front of you with an augmentation of the device. And finally, that sensor which is there at the top, that happens to be very similar to a massive IoT device. So inside a manufacturing plant, you actually get to see all these three different properties of 5G coming together. It's the perfect example of a 5G system. Let me end the entire note by talking a little bit about automotive applications. Today, we are spending a lot of time in terms of trying to take an automotive service and adding in the ability, adding cameras and sensors, and so you have level 3 automation is some of the work that's going on as we speak. But the question is there a role for wireless as a part of autonomous vehicles by itself? And the answer from our perspective is absolutely yes. Because radio-based communication complements cameras and sensors today by adding other pieces. You can now communicate with each other. One vehicle can communicate with each other in a non-line of sight environment. Imagine you are driving and there's other vehicle that's coming in from around the bend. You can't see it, so cameras won't work, but you can communicate with it. That allows for secure communication to occur for safety purposes, V2V. Imagine a vehicle that's driving in front of you and it slams on the brake. You can't see it, but you actually get the message. Immediately, you get a haptic feedback and you know what to do. But similarly, in addition to vehicles communicating with each other, vehicles can also communicate with all the infrastructure around them. We heard the example of toll booths in the morning. That's just a starting point. Vehicles can communicate with traffic lights, stop signs. I'm driving, 1 mile down the road, there's a traffic light, which is currently red, but it tells me if you drive at this speed, it's going to be green. Okay, I can use that information. Or maybe I'm driving, and there is a child who just walked into the street. There's a camera that's on top of the traffic light which sees it, processes it, and immediately broadcasts an information saying, watch out, there's a child on the street. It's a safety application. A lot of new things actually come in once we start introducing 5G capability into automotive sector. And we're just getting started with this. So I'd like to end the note, just about in time, by saying there's so many applications with 5G, but it's important to remember this is just the beginning. Welcome to the invention age. Thank you.